How can I use the Pythagorean theorem to find distance on a coordinate plane and in 3D? What? 3D? Well, start with coordinate plane. The Pythagorean theorem is a squared plus b squared equals c squared. So say we have this plane, and kind of ignore the red part first. And we have this map that shows like miles, right? And you have where Mr. Donnelly is and Mrs. Rogers is. And so you have these two coordinates. Maybe you know it's 1, 5 and 4, 1. And you have to figure out how far is the distance between them. Well, what you can do is draw a right triangle. So I've done that. I drew a line down here and then across this way. And I know that this line is 4 because from 1 to 5 is 4. And this line is 3 because from 1 to 4 is 3. So we know what we have is 3 as one leg and 4 as the other. So then I can do 4 squared plus 3 squared equals c squared. I have the two legs of a right triangle and I solve the hypotenuse. I square them, add them together, and take the square root, and I end up with c equals 5. And that's basically it. When you have 2 points on coordinate plane, you can use the actual distances you can just count, create a right triangle, and then use the Pythagorean theorem to figure out what the hypotenuse is. And the hypotenuse should be the distance between those 2 points. So that's the coordinate plane, right? So 3D, how in the world are we going to do that? What we're going to do is we're going to look at rectangular prisms, basically a box. And so I'm prepared here to kind of show that to you. I have some good mathematical tools. I have some string I'm going to use, right? I have a tape measure to do some measuring with. The string's going to help me with the tape measure. Those are going to kind of go together here. And I have a nice box that I'm going to use. This is basically a box. So I have a rectangular prism. And of course, I have a very useful lightsaber. All right? So let's continue on here as we go through. How are we going to do this? Well, what you do is here's the picture of my box. You can see I have length, width, and height labeled in red, blue, and green. And you can figure out the diagonal or the longest length possible that would fit inside a box from one bottom corner to the opposite corner on the top, which is three-dimensional diagonal. I can figure that out by knowing that on the bottom I have this triangle that's length, width, and then the hypotenuse, we'll call that C. And then so we figure out this C length, and then this C length down the middle, plus the height, are the two legs of another right triangle. So if we do a squared plus b squared equals c squared, I can figure out that width squared plus length squared is going to equal c squared on the bottom. And then this big diagonal I'm looking for would equal the height squared, that's one leg, plus the c squared that I'd figure out with this. So if I have the width, length, and height, I can use the length and the width, the length and the width to figure out this diagonal. Then I can go ahead and substitute that in here. So it would be the diagonal I'm looking for squared equals height squared plus width squared plus length squared, because those two equal c squared. So I just substitute that in. Now how can I do this? Well, what you do is you can take a box, and I guess you could cut it in diagonally to kind of see the inside. Let me go ahead and do that. That's what the lightsaber's for. All right, that's done. So now we have the boxes open up. And so we can see inside, we're looking at a triangle here on the bottom that would go this, and so this is kind of our width here, and this is our length. So we take those two, let's kind of give myself some workspace here. Pick up my marker. If we take those two, that would be kind of width squared plus length squared. So now if I get out my string that fell on the ground, here we go. I can use that to measure, but since this is a pretty easy looking box, it looks to be about 6 inches for the depth here, which I'm calling the width. So 6 squared plus the length, so how long this is. This is a little tiny bit less than 9, but I'm going to go ahead and say 9 squared, and that's going to equal c squared. So 6 squared is 36, plus 9 squared is 81. That would be 7. 3 plus 8 is 11. So 117 is going to equal c squared. I don't need to figure out any more. I don't need to actually figure out the square root. I could, and the square root of that's a little more than 10. And if I actually measure this diagonal, it's actually like 10.8 when I figured it out earlier. It's kind of close there. It's almost 11 inches. So it's about 10.75 maybe. So it works out about right. The square root of this is more than 10, less than 11, and that's where my inches fall in. What I'm trying to figure out is what's the length from here to here. Now if I stick this in here, it looks like it's close to 10 maybe, but no, not the length from here to here. The length from this bottom corner up to this corner. This is the length I'm looking for. And it looks like it's getting close to about 12 feet, 12 inches, 1 foot here, based on my ruler. So how can I calculate that without destroying the box, right? Because this box is destroyed thanks to that lightsaber. So now I would have to take this C, which is this line here, and then the height, and that makes a right triangle with this diagonal I'm looking at. So this length here, the height, appears to be about 5.25 inches. So we would take the height, which is 5.25 squared, plus C squared, which is 117, is going to equal D squared. So 5.25 squared is 27.5625 plus 117, which is 144.5625. So actually, I know 144, the square root of that is 12. So we end up a little bit over 12, which is basically what you get if you cut the box in half. I'm right around 12 here with my thing. So right around 12 inches. That's what I calculated using the Pythagorean theorem. Now my measurements probably aren't perfect, but close enough that I'm getting pretty close to what the actual results are. And that again is, so again, we can do the Pythagorean theorem twice, where we do width times length, and ultimately the formula that you can remember is that diagonal, that longest diagonal in a box is height squared plus width squared plus length squared. If you can remember that, that's kind of how it works. But you can also just do it twice like I did and work your way through it too. How can I use the Pythagorean theorem to find distance on a coordinate plane and in 3D? No more shocking. You got this, right?